So today we start on domain and range. And domain and range is so important. We're going to actually spend 3 days on this. So it's really important that we understand domain and range. It's not anything hard. We just have to pay attention to the details. Okay? So domain is a set of all input. It is the x value. Okay? It is also called the independent variable. And independent variables and dependent variables are the same as we were talking about them in science. So there is a correlation, there is a connection. They mean the same thing, both in science and in math. So it's important that we pay attention to that and we use it correctly in both places. So the domain is the input. The range is the set of all, you probably guessed it, output. And those, of course, are usually the y values. These are called the dependent variables. Now what this means is that y depends on x. That's supposed to be, say, dependent. Let me spell that a little better. Dependent. Okay, so y depends on x. X is its own free little will. Now the other thing I want to tell you that might help is see how x and y are alphabetical. Notice that domain and range are alphabetical. So domain is the first, range is the second, first and second alphabetically. So that might help you a little bit remember these. The examples below are all ones that include discrete data. Okay, that means that the values of the function can only take on specific values. Graphs with discrete data consist of individual points. Okay, these are sometimes called scatter plots because we're just going to plot points and they could be any place. Okay, but discrete means that it has to be like just a whole number. You'll see in almost all of these. It's usually going to be whole numbers. When describing the domain and range of discrete data, list individual values in numerical order. Do not duplicate. Do not repeat or duplicate values in this list. So do not duplicate repeating values. Don't write them twice. Write using set notation, so we're going to use those little fancy brackets. Okay? So when we look at domain, remember domain, x value, range is y value. So all I'm going to do is I'm going to take the x values and write them in set notation. So I make my little brackets and I write 9, 5. Oh, but look, there's 2 5s, and notice it says we do not duplicate them. Okay, because we just have to state what the domain is. So we don't write both 5s, and then we have a 4. Okay, that is our domain. Now our range are y values. So we're going to look at our y values. Again, make your set brackets. I write 1, 3, 7, 8. Now they want us to determine if this is a function or not. So we look again at our x values. Look at our x values. Do any of them repeat? Well, yes, they do right here. So this is not a function, no. But remember that it is a relation. Okay? We knew it was a relation to begin with because it could be written as a set of ordered pairs. Okay, so here we go. Now this is where mapping is really handy to write the domain and range. Okay, so here we go. The domain, just write down your x values. -1, 0, 1, 2, 3. Okay, did we have any repeating values? Let's just go ahead and determine the function now. Do we have any repeating values? No. So this is a function. Yes, it is a function. Okay, let's write our y values. So we just go 3, and they've already taken care of, if it duplicates, they've already done that for us. So we just have to write down what they are and see how 5, if we were to write out the ordered pairs, 5 would be written twice. But because we don't duplicate repeating values, we don't write down the repeating values, we're done. Okay, so those are pretty nice. So domain and range, what I'd like you to do is right now pause your video and write down the domain and write down the range. Okay, pause yours and do it, then we'll compare answers. So our domain goes with our x values, our range goes with our y values. Is this a function? Okay, well, hopefully you noticed we had 2 4s for an x value. So no, this is not a function. It, of course, remember, is a relation, but everything on this page is a relation. Okay, here we go. Now on this one, we have to actually find the x and y values. If you want to write the ordered pairs to begin with, it sometimes is easier, or you can just write down the x values. So I'm going to show you both ways. So if I wanted to, I could just write down the x values. The x values are 1, 2, 3, 4, 5, and 6, because the x values goes along with right down here on the x-axis. Now I'm going to write the range. Okay, so this one has a value of 3. Now this is where we're supposed to write these in numerical order. Okay, so we have to go from lowest to highest. So if we're going to do that, we would have to start with our y values down here. So you can see why it might be nicer or easier if we wrote out the ordered pairs. So here we go. My lowest y value, because this is my y-axis, my lowest y value is -1. So I don't want to just go left to right. I want to go lowest to highest. My next one would be 0. Okay, now my next one is 1. My next highest one is 2. My next one is 3. And then I go all the way up here to 6. Okay, now is this a function? A lot of times it's easier to go back to the graph. Does this pass the vertical line test? Where is our ruler? Oh well, we'll just have to go with the pencil test. Look at that. Does it hit more than one at a time? No. So yes, this is a function. Function. Okay, so this is all discrete data, and if we would plot it, it would look like this. We're just going to plot individual points. This is what's called discrete. All whole numbers. Notice no fractions. Okay. Now on the back, the examples below that we're going to see here, these are all continuous. Continuous data. That means that the values of the function take on all values. Graphs with continuous functions are data that are unbroken, meaning it's not just dots. It can be drawn without picking up your pencil. Now, you're going to a lot of times pick up your pencil, but it could be one continuous graph. See how, okay, so we're going to come back and do domain and range, but see how I could draw this all in one. Now, this one might be a little tricky. You might pause, but you don't have to pick up your pencil. You might pause to draw this one. See how I can draw it in one continuous thing. Okay, so now we're going to use interval notation. You remember when we did with this with inequalities, interval notation when writing domain and range. Parentheses mean that it is non-inclusive. So it's not part of the solution. Or it's infinity. Because infinity, we can't stop at a certain point. Our brackets mean that it's inclusive. It's part of the solution. Okay, so non-inclusive would be parentheses and also infinity and negative infinity. So that's what we need to understand. Interval notation, okay, remember goes from smallest to largest, and you're going to see that as we do it right here. Okay, now on these problems, it's actually fastest if we go through and determine our if they're functions or not, because we can use our vertical line test. Found my ruler, so we can just go by vertical line test. Look at that. Is that a function? Do I hit it more than once as I'm going across? No. I hit it one point at a time, no matter where I place it. Now I can hit it lots of times, but every time I place my vertical line, no matter where it is, I'm only going to touch once. So yes, this is a function. Okay, what about this one? Go across with our vertical line, Do I touch it more than once? No, I do not. So yes, that's a function. Okay? Look at these down here. Oh, bam! All over the place. Not a function. Of course it is a relation, but it's not a function. Okay, what about this? Well, here I only have 1 point, but here I do not. So this is not a function, but it is, of course, a relation. Now, these are functions and they're also relations, because remember, by definition, a function is a relation, just a specific one. Now let's talk domain. Domain, remember, are your x values. Okay, so what we want to do is we want to look at what our x values are. Everything, okay, what are our x values? Does it stop at any point, or is it not part of it? No. So our domain, our x values go on forever and ever and ever and ever and ever and ever. Okay, so our domain goes from, whoops, what am I doing? Wrong page. Domain goes from negative infinity, and we always go smallest to largest, to infinity, and whenever we have infinity, we have to use parentheses because it's not locked down on an exact thing. Our range, now our range goes from top to bottom. Is there any restriction on when our range changes? No. So our range also goes from negative infinity to infinity. Okay? That's going to be true of a line all the time. Now let's look at this one, our domain. What are our x values? Are there any restrictions on our x values? Look at this right here. These are my x values. And see, with those arrowhead, that means that it continues forever and ever. So our domain continues forever and ever. So again, that's going to be negative infinity to infinity. What is it with me and this? It has to be a parentheses, sorry. Now range. Okay, now here range does have a restriction. See how range has to go from here on up. So range goes from here on up. I'm looking at my y values. Remember, y is your y values. What can my y values be? Well, they can be 0 on forever and ever and ever and ever. They just keep on going. So my range goes from 0, which is a point on my graph. So that is included as part of the solution. And then it goes forever and ever, so it goes to infinity, because it goes in the positive direction. Okay? And as you're doing your homework, if you have questions, try it, and then again, come into class and ask me questions. Now, here we go. We're going to look at our domain. Now, our domain here starts right here. See how our domain goes here, and then it goes on my x-axis. Now, my graph I know is going up here, but if I'm just looking at my x values, these are all the x values. There's no graph over here, so my x values don't go over here. So I start right here at 0 and go forever and ever on my x-axis. So my domain is 0, and 0 is part of my graph, so it's a square bracket, and then it goes on forever and ever in the positive direction. Now my range, looks what's happening with my y values. My y values, if you look at your graph, see how it's going out like that, and then it's just going to continue forever and ever? So my y values continue forever and ever and ever. So that's going to be that it goes from negative infinity to infinity. Everything is part of it. So if it's everything, it's going to always be this negative infinity to infinity. Oh, this one's fun, okay, because everything has restrictions. So look at our x values. My x values go from here, sorry, that's all I had, to here. So look at that. If I draw it from here to here, if I'm looking at from here to here, what are my x values? Well, it starts over here. Gosh, it's hard to read those numbers. 1, I don't know what the heck the numbers are. Let me see if I can find more information. Okay, so it's a little hard to read, but this line right here is -10, and this line right here is a -2. So that means that this is 2, and this is 4. Those numbers are hard to read. So if I'm going from here to here, okay, what are my x values? Well, my x values start right there. Well, that's just short of between -8 and -10. So they start at -9, and they go to, what is that? There's 2 right there, so they go to 3. So my x values go from here to here. They go from -9 to 3. So my domain, and now that is part of the solution. If it were just a dotted line, a dashed line, it wouldn't. Okay, now let's go the other direction. Let's look at our y values. Okay, our y values go from here to there. What is that point? We're going up by 2's again. So 1, 2, 3. So it goes to negative, it starts at -3, goes all the way up to 2, 4, 6, 8, 9. So see how this one goes, here's 9, here's -3. So it goes from -3 to 9. Okay? So that's the reason what you want to do is x values you want to look from here to here. It's on the x-axis. Y, I want to go from here to here. Okay? Good. Let's look at your homework. So your homework is this sheet right here. And what you're going to need to do is go to Schoology and go to Thursday for your assignment. And let me see if you actually see. I'm hoping you're actually seeing my screen right now. If you are not, then I will do another video. But you go here to Domain and Range Task Cards. When you open that, I would suggest that you open it all the way up so you can read it. And then what you're going to do is each task card, it's going to answer the same questions when we do like we did before. We're going to look about what is the domain, what is the range, and then state if it's a relation. Is this a relation, a function, yes or no? Okay, and you're going to go through and do each one of these just like what we've been doing. And then you go to the next slide and you answer those questions, okay? But you'll see it's just like what we've been doing. As always, if you have questions, just ask about it in class. Thank you.